population, the dynamics, the catch-up, everything is happening in the group of developing countries. So that's why the growth is there. And the growth is there despite water scarcity, but water scarcity affects that growth. So basically, the assumption is, or the proposition is, that growth would be much faster, or would be faster, I don't know how much faster, it would be faster if they would not face water scarcity. And basically, what we did show is that to stay at the water scarcity levels under business as usual, to stay at those levels and achieve higher growth, you need blue water productivity. So we can show, the question is what indicator do you take? So we use water scarcity, and to have higher growth without higher water scarcity, you have to use blue water productivity. That's what was kind of the last message. So, but despite that, correctly, we see high growth in Africa, in Asia, and that's where a lot of the water scarcity is. But that's where all the dynamics and all the growth occurs. Despite water scarcity, but it would likely be larger. I mean, places like the Yellow River Basin, obviously in North Africa, you would see a lot more growth if you had more water. But then you would have to do different kind of case studies to look at that issue for each specific basin in each country. And then if I had a lot of money, what I would work on in terms of water productivity. So the issue is there's no magic bullet or silver bullet. You would have to work on several areas, but generally I believe that investments in agricultural productivity itself, so improve the seeds, heat, drought tolerance, stress tolerance, that will all have yield improvement impacts. So that's probably you'll get the biggest bang for the buck in terms of improving global water productivity. Definitely not domestic or industry.
Thank you, Claudia. Maybe you could leave one of the maps in the background, which showed results. There's a lot of knowledge in the audience here related to certain water in certain regions of the world, be it West Africa, Central Asia, the Mekong, South Africa, and so on. And we moved a bit fast when we looked at some of these maps. So if I look at West Africa, I see lots of green. Vietnam doesn't seem to be a trouble spot. That is orange, if I get it right.
No,
here.
Vietnam's green.
It's green. Good for Vietnam. South Africa, Egypt, Central Asia is where the problem needs to be solved, and that's why our research is there. Anyway, that was an interjection. More questions. Don't need to be regional. And feel free to ask Claudia also methodological questions, because you asked us to believe what you presented. So ask about background, modeling, etc. Anyone who wants to take that? Mark?
Yeah, Mark Müller here from ZEF. I have a question related to the scenario construction, basically, and then the results you derive from that. So you construct your scenarios based on assumptions related to growth, sectoral growth. And then the simulations result in cross-country differences in water scarcity. And so I can understand that, of course, that certain growth paths may or may not cause water scarcity. However, on slide 14, I think it was, you,
This one?
yeah, water stress will pose a risk to growth. That, to my understanding, perhaps I got it wrong, that seems to revert actually the reasoning in your model setup. So could you please clarify on that?
Yeah, I mean, I agree the formulation, you should only actually use the formulation if you look at the differences across scenarios. As I said, if you want to have higher economic growth at the same water scarcity levels, you have to increase water productivity.
Oh, okay, so you don't actually specify the impact of water scarcity on Europe.
Because we don't have a CGE model. Yeah, that's why we can't do that. So economic growth is an input factor. So if we use a global GTAP water model, you could get at some of that, but then you usually cannot get at some of the regional disaggregation. So I think overall results might actually show less scarcity because of the lack of disaggregation in most of those CGE models. So it's kind of a trade-off, yeah.
If I just may quickly add, I mean, couldn't you think about scenarios, at least where it is possible, that water scarcity can have a positive impact on growth? Just really like as a perhaps provocative hypothesis, that what you can observe is in the context of other natural resources, that scarcity of a natural resource can potentially have a positive impact on growth through diversion of investment, perhaps in other branches of the economy.
Yeah, I mean, it's a combination. You might see some migration, right, out of extremely water-scarce areas, so that could be beneficial. So, in the long term, so if you move out of those water-scarce areas and you move into more water-abundant areas, it's probably beneficial for growth long term. And yes, I mean, water scarcity has, similar to food price, high food prices. Water scarcity is, you need serious level of water scarcity to actually start to invest. So, for example, the Yellow River Basin, I mean, investments are in improving water use efficiency. They're very, very, very large, and they're trying out a whole variety of tools, from pilot water rights trading to increasing water prices and irrigation. So yes, I mean, obviously it's a little bit costly, and some people will lose out, but overall economic growth is increasing. Or what also happens in the Yellow River Basin, because you have scarcity, so industry and domestic sectors come first. The benefit, the economic growth in the basin is much larger from industrial development than from irrigation, from agriculture. So the water moves out of irrigation into industry, you have higher economic growth, yes. But obviously there's some other effects on food prices. So definitely water scarcity, if the focus then shifts to moving all the water into the highest value uses, especially industry, then you can have higher GDP growth, but at the cost, of higher food prices, which again don't affect everyone equally. So if you can afford higher prices, you're fine, you're okay. So it's interesting, but yes, if you think it through, you can definitely get higher economic growth in water short areas if you have the industry.
Well, why shouldn't there be a Boserup hypothesis for water, as Esther Boserup has found what Mark Müller hypothesized for land use, that increased scarcity can drive positive productivity. So that, but that calls for another model, basically.
Yeah, again, the formulation you had used, reorganizing priorities for water allocation, and we concluded that's one of the tools. To what extent is this model taking seriously the situation that in many cases of increasing water scarcity, it's nothing about priorities and water allocation, but how to distribute the already growing deficit. So it's a different notion. There is nothing to trade, and especially in the debate about bioenergetic fuels and other things, there's always the critical question, are we dealing with something in the reasonable time perspective? For example, if we will consult the next 20 years with Libya, how to reallocate the water that is taken from the fossil groundwater, which will come to an end in 20 years anyhow. And there are other situations in the world where we are going exactly into this direction, that we are very close to the point where there is no distribution to be thought, but only a distribution in the amount of increasing the proportion of the need to increase the efficiency.
So if I understand you correctly, you're saying we shouldn't, so what we currently do is we prioritize domestic, industrial, and livestock water use. So their demand is fulfilled first, and whatever is left over is available for irrigation. So this is how the model is set up, which just improves, it's fast, it can run faster. Alternatively, we would have to put a price and allocate the water across the sectors, and the result would basically still be the same. So when we basically reduce the time it takes to solve the model, and there is sometimes you have a proportional reduction across users, but in 9 out of 10 cases, or 99 out of 10 cases, domestic, especially domestic demand is basically all the legislation has first priority under water stress, water scarcity situations. There's some cases where industry will have to reduce proportional allocation when we have real water scarcity. And then obviously, if we have that, if we don't have enough water for domestic industry and livestock, they will see a proportional decline, but then we'll have obviously nothing left over for irrigation. So generally, we have seen many cases, and especially in developing countries, when there is water shortage, it's really irrigation that does not receive the allocation, and it's definitely like yellow river basin, Indonesia, etc. This is what happens. But
Annika, I think, is next.
Claudia, very nice presentations. I remember of a cross-country econometric study finding out the effect of water scarcity on economic growth. And that study found is the inverted U-shaped relationship between water scarcity and economic growth. As economic growth increases, water scarcity increases. Then if the economic growth further increases, water scarcity it starts falling because they generate more resource. Like in India, if there is growing, then they can link to the rivers. Not considering the environmental cost. So they can afford to do that. In China is doing that, then the water scarcity will drop.
Which is basically, we're talking about increased water productivity.
Yes, and at the local level, and I've seen many farmers in Andhra Pradesh, they are using high capacity pumps, and to grow tobacco. In Andhra Pradesh.
That's not necessarily sustainable, but yes. So that's exactly, there is what we can call autonomous adaptation to water scarcity, which is like autonomous adaptation to anything else. So prices go up, things become scarcer, we are investing, we are increasing productivity. So there's no doubt of that. And basically here we just posited 3 scenarios. And obviously, even under business as usual, this is not like, it's not a fix, we're already improving, we're already improving efficiency. And it's both, it's a question of investment, and it's also a question of just adaptation to a scarce resource situation. In India, they're starting to invest in desalination and everything. They're not just waiting till there's nothing left, but they're still moving extremely slowly on basin management, on crop productivity improvement. Instead of desal, which urban, they have the money to pay for that. The urban sector, they could do a lot by changing some of their policies, like the subsidy policies on electricity, etc. So
Claudia, let me paraphrase as how I understood Annika Duri. So you have, in these scenarios, not been able to build in the non-linear relationships between water productivity and growth. There's
that's
no
why we did the
growth water Kuznets curve.
No.
So it's linear or fuzzy, just to be blunt. Okay.
Which is why we do these various scenarios. And then you have to compare across scenarios.
But within scenarios, there's linear relationships between growth and water productivity.
Yes, because growth, exactly.
Okay.
Because growth is not effective, and you can't do it in this partial equilibrium.
Okay. Next, please.
Daniel Sakai from ZEF. One of your concluding remarks was on domestic and industrial sector. We can save a lot of water by improving water productivity. But when it comes to like South Africa and other developing countries, and this irrigation is a lot more inefficient than the other sectors, and they are trying to focus, just trying to deallocate water from irrigation and completely to other sectors. So how applicable is your conclusion to Africa and other developing countries in Asia?